Okay, let's say I've made a program. It's supposed to draw a rectangle, white rectangle on a black screen. Okay, I've calculated the y, added the x, all that, and then draw some stuff, a white pixel. When it gets to the end of the row, move to the next row. Okay, so it should draw a rectangle at 50-50 in x and y that is 100 pixels wide and 50 high. Good to go. Okay, so let's have a look over here. And whoa, I got a white screen. Apparently, I have some overflow somewhere. I don't know where. You know, let's say it's late. You know, I don't feel like taking this apart and playing guessing games. You know, it'd be great if I could just like slow the program down or something, so I can like step through it and see where this overflow occurs. Does it happen at the end? Does it happen at the end of the first line? I don't know. It'd be nice to look under the hood and see what's going on. Well, there is actually a way to do that. To make a long story short, so interestingly enough, let me go back to where I just was a second ago. Let's say I do my NASM thing. Right, there it's already NASM'd, right, so I can run QEMU, right, but in the QEMU documentation, I discovered, not why, if I add minus S and then minus capital S, it launches the program in a paused state. Wow, that's great. So that means that I should be able to just go up here and go step, and it will go to the next. No, it doesn't allow that. Okay, great. Well, you know, because what? It assumes you can't just like hit the escape key or whatever, step through, because maybe your program uses the escape key. It doesn't know, you know. So, so therefore, okay, so they maybe included an option where you can create I'm not using the escape key, right? And I should be able to make a user-defined shortcut. No. Okay. Instead, you have to use an external device, right? Okay. In this case, it means you have to download more software. Okay. So one way to do that was with the GNU debugger, and one way to get the GNU debugger is you can download, was it MinGW, comes with that, and then now you also have the ability to, you know, compile C programs and other things, but the GNU debugger is part of that package. So I tried the MinGW thing, wasn't 100% satisfied, and so I looked around and I found another method, which is actually written by the Unix guys who were doing this stuff while these Linux guys were still in diapers. Let's see, before I get ahead of myself here, what I want to do this time is, so like a moment ago, we called the x86-64 emulator, which we've been using. Our code is backwards compatible, run on a modern day multi processor unit. It'll run on a 486, a 386, a 286. It is way backwards compatible, you know, because you know we're working in 16-bit. But from what I've seen, I don't think anybody's actually made the software yet that connects to the 64-bit version, but the 32-bit version is out there, so that's what we're going to use. So instead of that, hang on a sec here, I just want to, we're going to use 386, like that, right? Okay. Hang on, let me just make this a little bigger so you can see the full path there. Adding in the minus S and the capital S will launch us in a paused state. I assume if I can get it to go. There, okay. Okay, we have launched QEMU. The 386, we are emulating a 386. Wonderful. Now, to step through it, I have let me hold this over the mouse over that for a second, MSYS2. Okay. And this is really cool. I wish I'd have known about this from the very beginning, to be honest. If I had, this whole tutorial would have started from here instead of going, to the command prompt, right? The built-in Windows thing. And then we had to go and download NASM and download QEMU and then set the paths to all that. Well, if you simply download this one program, MSYS, then you can run a couple quick commands and it will download NASM and QEMU and set the path all automatically, and you can do your assembling and debugging all from this command line instead of the normal one that we're used to. So had I known, this whole tutorial would be using this instead, but now I'm kind of used to this. We'll be using a combination of the two, I guess. Depends. We'll see. So, in other words, I could also, from here, just as easily, if I'm in the correct folder, right, go to paste. I can run NASM and compile, assemble my program from here as well, right? And then I can run QEMU and all that. First things first, let's see. I want to be in the right folder for one thing. So that is a little bit different. Normally in, let's see here, let me just... Normally, if I want to get to my assembly folder where I'm doing my stuff, this is my path, right? Okay. This is written using a Unix syntax. So the paths that you define are a little bit different, like that. Okay. So a little bit different. So I'm going to go up here and change my path to there. See, and it tells me now I'm in my assembly folder, right? So like I said, I could now run NASM from here, well, let me just do it. It doesn't matter. Does not matter. There, paste. Yeah, it assembled it. It doesn't give you any feedback, but it did. So I just reassembled my binary, which is doesn't matter. It's already running over here. Okay, and then I could also launch QEMU from here if I wanted to, just as easily. Womp. Same thing, but it's already running here. I don't have to. Okay, see, but I could do all this from this command line now. Okay, just to illustrate. Okay, so now I'm going to go launch the GNU debugger. Okay, and I want to tell the GNU debugger that I want to communicate with this program over here. This program over here has an assigned number, which is 1, 2, 3, 4. So I'm going to use that to connect. I'm going to target my remote locale host 1, 2, 3, 4. Oh, whoops, not low. Locale. There we go. And ding. Okay. So it says some stuff that throws you off, but we're semi-connected now. Let's make sure we are in the correct folder now. So the path is here. I've earlier, what did I say here? C/users and everything. From where we are now, I only have to go users, your name, documents, assembly. Okay. There. Okay. So now we are in the correct folder. Okay. So my program is running, but if I just go run, it'll go vroom, it'll just run the program, which we don't want. We want it to stop somewhere. An easy way to do that, I can say define a breakpoint. Break asterisk and then the address of our program in memory, which we have told it that we want it to run at 07C00. So if I set a breakpoint there, then it will pause at the beginning of my program. Nifty. So I can type continue, and wow, there, it's beginning to boot over here now. you see. But we're not far enough into our program for it to actually do anything yet. Now that we're here, okay. I could set more breakpoints as I go, ad hoc, or I could kind of set a number of breakpoints in advance, you know, breakpoint 1, breakpoint 2, breakpoint 3, etc. But where exactly do I want to put them? A good way to help figure that out, I'm going to examine my program in memory, I guess. 20 instructions, beginning at the current program counter, which is $PC. Okay. There. And it says this is the line of code that we are currently on in our program. Here, let me go over here. I can get rid of this and go up to the top. There. Move value 13 in hex. See, 13, 19 in decimal, into AX, EAX in 64-bit, you see. And then does some other stuff, and then call subroutine at this memory address, you see. That's a 64-bit representation of the memory address. Okay. There. So here, that's where we are now. The next jump point, so to speak, here's a safe jump point. I could illustrate in a moment. I could jump. But I could set to this jump point, to this jump point, to any of these, and that is a safe place to jump. You see, if I jumped, say, here instead to 07C04, then that would be, where are we here? Add, whatever. That would be like saying jump here. You follow me? But here, it has conveniently grouped everything into rows, sections of segments of code, you know, and it tells you the first one is a total of starting at 1, it would be, you know, 5 bytes, see, and then the next one begins at A would be, you know, 10, see, another 5 bytes to the next set of instructions. You see, so this grouping helps you set some more breakpoints. To make a long story short, which I usually make a short story long, don't I? So back to here, there's GDB. We're at the command line. I can set some more breakpoints. And instead of typing break for a shortcut, I should also just say B. So I could say OX7C05, like that. There, and it sets a second breakpoint. And then you can jump to them by name or consecutively, or you can add more or delete more. I'm going to add a couple more, I think. Here, let me just do it this way. I'll highlight that and right-click copy, and then go B space asterisk and right-click paste. Bink, like that. There's my third breakpoint, and one more would be this one. Copy that. B, like, whoops, B, I'm sorry, right click. I'm trying to Control V, paste there. Or Shift Insert. Right, because we're in a Unix paradigm here now. Okay, this was ported over from Unix to Windows, but it still retains all the paths and everything from working in Unix, right? Okay, so that's enough for now, I think. So if I go continue, it will jump to breakpoint 2. I'm already at breakpoint 1. That's when I typed continue. It stopped here. So if I go continue again, oops, wait, I haven't hit enter. There, 4th breakpoint is sent. I could type continue or just C for short. There. And we have jumped to breakpoint 05, and if I'd have left this over here, you see now we got a black screen. We are no longer where it said loading programmer or whatever it said, right? Okay, wow. So we are clicking right along here. At this point, you know, I could begin stepping through my program if I want, or I could have done that at any time. So I could go next instruction and begin. Okay, so now instead of now I'm at the next, I'm at 08, right? And then if I go, I could type next I again, or I could type NI, and it will go to the next instruction, right? Or I could just keep hitting enter. And it goes to the next instruction. Next instruction, next instruction, next instruction. That's weird. It went to the next breakpoint instead of NI, next instruction. There, okay. So let me just continue here. Okay, so enter, enter, enter. We are stepping through the program. And look, oh, a pixel just appeared over here. See? So keep continuing. Like that. Interesting. And you can hold it, you know. So there's my program running in slow motion. This is what it's, if I'm drawing a rectangle. There, it's 100 pixels wide. There, it started the next line. Right. Oh, cool. Okay. So obviously the next line is cool. And sometimes if you're holding and you let go, it'll keep going a few. You know, it's not doing that to me at the moment, but it has in the past. So I'm just going to go like this because I already know what's going to happen. Oh, you see that? It keeps going. It didn't go back to the next line. Oh, I have found my overflow problem, and it will continue doing that. So I could, at this point, go info registers and see what's actually in my registers. You know, again, I could have done that at any point as well. And once you are a little more familiar with what it is you're looking for, you can go, oh, okay, I see. Well, you know, SI, I did some things wrong. Oh, right. You know, very interesting. Another, let's see. Return for more, you know, return, look at a bunch of other info, and it returns me back to GDB. I could also, if I want to see a little more than just the registers, you can go layout, ASM, and you get this kind of split screen thing, right? It says no assembly available. So I have to disassemble my program into something it can read. Disassemble. From the beginning of my program, OX7C00 comma OX7D00. There we go. There, so it gives me something to look at, you know. There you can see there are, the breakpoints are listed. There's a breakpoint, there's a breakpoint, there's a breakpoint, there's each of our commands, you know, and we can step through the program, you know, see changes there. And there's also some different viewpoints, layouts, which, was it layout registers, I think is one. Yeah, there. I can see the small group of registers, not the full group that we saw earlier. Okay. Now, from here, I don't know how to get back to the full register group, how to make all of this go away and look again at the full page. And you can't resize these. They're kind of a fixed size. I could make this part bigger down here, but I can't resize the window, so it's somewhat limited, you know. Let's say layout registers. I could also go layout next, and it will flip me through various views. There's one. Now I just disassembled the source, but it tells me no source available, so I have to disassemble it again. Wonderful. No assembly. There's a split view, source and assembly together. So if I disassemble, this one is generally, kind of useful, because I can continue going next. Next instruction, but first let me disassemble. Disassemble. OX7C2 X7DOO. Oops. Okay, not the view I was expecting. Hang in here. Okay. Q to quit out of this. Okay. This is source. Source is when you have, a C program. So this has more advanced features where if you have a higher level program, C program or C++, it can display your program here, and then as you're flipping through the program, it will show you where you are in your code, but it's not as advanced when you're working in assembly, unfortunately. What was the one I did like? Layout next. That one. No source. There's the register. No source. Where is it? Here, assembly. Let me try this one. What was it again? Disassemble. Jeez. And why you have to do this every time is X7DOO. There. Okay, so that's kind of nice. If I'm going next, there. Okay, there. I can see there. One of these registers has just changed. This one has been updated, so it's highlighted, and we are seeing where we are in our program, which we can compare to our actual program over here. We don't get to see it in a window and it shows you what line we're on like we would if it were a C program, but you can kind of go, oh, okay, I see I'm in a loop now, and over here it's going on, it's going around in some loop or whatever it's doing, so if I go continue hitting enter, there, I'm flipping through the program, seeing any changes that are going on, and the beauty of it is I can actually see what's going on in my actual program over there. You see, it's caught in this endless loop somehow now. See? So very useful. There is how to use GDB with MSYS. And there was some setup things. Like I had already installed MinGW. So I could do this same thing in the GNU debugger, GDB, all right? And then when I went to install this one, MSYS2, it didn't recognize the already installed GNU debugger, So if you have MSYS, MinGW, if you already have MinGW installed, what I had to do was uninstall GNU debugger and then install MSYS2, and then from the command line in MSYS2 you can say install the GNU debugger, and now it's all set up to recognize and everything. So yeah, just one minor complication. So in order to set up, let me see if I can, all right, let me just assume, I'll get out of here. that I quit. Yeah, kill the process. Yeah, there. Now I'm back at the. I'm out of GDB and back in my command line thingy. Just get this one out of here for now. Now let's see what happens if I go CD squiggly. Yeah, that looks more familiar. I'm down at root. That was my error. Notepad dot bash rc. It launched Notepad in my other window, but there it is. And then you get this list here. And it's all comments. The entire thing is comments until you get but it's some kind of code, I guess, that it recognizes. Hang on. Can't see the bottom. Let me get up here. Go down to the bottom. And then here's what you have to add. Export path, user bin. Here, just this much. Export path, user bin. Also, and then also, you want to tell it to look for min.gw, bin32, min.gw64. And then if you have an existing NASM, okay, you can link, set the path to that, thusly, using the Unix syntax. I'm looking in my C program files, and when there's a space, you go \space to whatever to say that this is a space. Yeah. Program files, NASM. There. That's it. Oops. That sets the path to my existing NASM, assuming it's where we installed it in your program files, right? And then set the path the same way to QEMU, and we are good to go. Save that, okay? And then you go out of there. Now that that's all saved, you head back over here and you type source squiggly /.bash rc, and now your program, this command line will recognize your existing NASM and QEMU and stuff, all right, which I've already done, so I don't need to run that. And then once you've done that, you can check to see if everything's running by just going NASM -- version. And if it tells you what version, then you know it's working. You can also, check for GDB. Is it -v also do the same thing? Yeah, tells you the version of the debugger, QEMU -v. All right, QEMU is a big long. There's a bunch of different flavors of QEMU. I won't go that deep into it. Okay, but yeah, so there, everything, all the paths are set now. See, so yeah, this is a pretty handy tool as well to be able to run a rudimentary debugger and look at things on the fly, and also just slow your program down so sometimes you can see what's going on. There you go. That is GDB running under MSYS. Here. Where is it? MSYS2. Yeah. Different flavors it comes with as well, but we want this one, MSYS2, the purple one. Yeah, okay. And that is a nifty little tool for debugging QEMU. Okay, so once more, this is kind of interesting. Let me just do this from MSYS. I will first go to my current directory. And then let's NASM. There. So my file is NASM'd from here. Then we'll run QEMU with the pause command from here. Okay. So once that is launched, I can get that out of the way. I can open another by right-clicking here, open a second shell, okay, and then we'll launch GDB, target our host, local host 1, 2, 3, 4. Like that. Okay. Now I want to make sure I'm in the same. I'm at root, so I want to be in the assembly folder where my file is. There. Okay. Let's set that breakpoint first. OX7COO. Good enough. Now I'm going to continue. Okay. So now if I go next instruction, it steps to the next. And I'm just going to keep hitting enter. And then boom, it jumps from here in memory to way out here in memory, because we are here. We are initializing. Wait, no, I'm sorry. We are here. We're clearing the screen. Initializing video memory and clearing the screen. Okay, so it's jumping to a video memory location. This is very interesting behavior. I'm just going to start flipping through here. And this will take a few minutes, and then you'll start to see some little blinky action going on over here. Like that. So something's going on. It is, as near as I can figure, it is initializing video memory, and we are actually seeing it, which I'm not sure if that's what it's supposed to do, but there it is. Okay. So that may take a few minutes, in which case I can always fast forward in the video. And then at some point the whole screen will kind of blank out. Okay, at this point the cursor went away for a moment. Something's happening. Cursor comes back about 30 seconds, 45 seconds later, goes away, comes back, goes away. So we're getting this blinky action. We'll do that 10, 12 times. Changes the font, and this is what I think is cool. This is now we're seeing the actual video memory, whatever garbage happens to be in there. There was this artist Yakov Agam who did artwork kind of like this because he was Jewish Orthodox and couldn't paint people, you know, so I do this abstract stuff that's reminiscent. So anyways, if I continue now stepping through the program, I found this very cool. It'll hang on this for another 8 or 10 frames, and then here, let me maybe more than 8 or 10 apparently. There. Now we are, every 2 ticks we are writing a black pixel to the screen. So what you're seeing, not in real time, but in slowed down real time, the screen being cleared 1 pixel at a time, just like that. See? And we'll just continue on our merry way here for a bit until the screen is completely cleared. Okay, getting down to the last couple lines of screen refresh. There we go. Well, last 4 lines. There we are. And then once the screen is entirely drawn, what happens? I'll go through a few commands. We're still looping around in 2B7A for a bit. Oh, what's this? 3.5. Okay. We've suddenly jumped somewhere else. 3.6. Yep, we're jumping around a bit. Let's see what happens if I enter our program. And there's our pixel beginning to draw, you see. So I just thought that was interesting, watching the entire process of memory, video memory being loaded, and then clearing the screen 1 pixel at a time. And then once you see that that video garbage thing, you can't unsee it. You know, from now on, whenever your program starts up, you'll see that momentary instance of a flash when there's these colors before the screen gets redrawn, right? Okay, so yeah, debugging, very useful tool. Okay, let me run over some of the basic commands for GDB real quick that I have so far. You can find more online tutorials that are more extensive than what I have done. Most of them are for C programs or writing your own, debugging your own operating system, a little more complicated, basically giving you everything I have. So page 1 up to step. Let me page down there from step down to delete breakpoint. And a lot of these, like some of these commands are specific again to if you're doing a C program or something, breaking into functions and such, jumping to a function name. Yeah, but then there are some that are that you can use specific to assembly, next instruction, and that also have shortcut names. Next, step, next instruction, continue, etc. we have done. So here you can get a little bit more info on things that you can do, and also, let's see, oh yeah, list all your breakpoints. When you set a breakpoint, like 1, 2, 3, 4, and then you can go list them, and it'll say 1 is at this address, 2 is at that address. Then I could go delete 3, you know, if I don't want that one, and you know, so you can add or delete breakpoints, right? Let's see, quit out of the program, step to the next layout. We did layout register, split. When we went next, it went through a split layout automatically, right? Things more related to debugging programs and higher level stuff here. If you have variables in your program, you can get a list of those. You can follow a variable, you know, which I haven't tried that in an assembly program with a variable yet, whether it will follow it or not. Probably not, because it has to create this special file to communicate with it and stuff. Oh, and here's the one I was looking for. Useful. Info GDB will give you the manual, so you can look it up yourself and scratch your head and try and make sense out of it. I have just given you the basic because that's as far as I've gotten. I'll look into it further and report back my findings as I find them.